writing down the first few terms of this series, we're going to have 200 plus 197.5. And you can see actually each term we're minusing 2.5 from it to get the next one. So the next one is going to be 195 and so on. So we're interested in the sum to n terms of this series and in fact the largest positive value of it. So it's going to just get smaller and smaller down to 0, and in fact it is going to equal 0 exactly. And one way we can figure out like how many terms they're going to be is by simply doing 200 divided by 2.5 to see how many times it goes into it. That's the same. You could double both to give 400 over 5, and that is 80. So there are 80 terms basically between 200 and 0. And if we want to check, we can do un is equal to a plus n minus 1d. That's our general nth term of an arithmetic sequence. So u80 would be 200, the first term, plus 79. Now actually, I'm going to find out what u81 is because that will be a little bit easier. u81 would be 200 plus 80 times minus 2.5. Now I'm going to halve this one and double this one, and you can see it's a bit easier to see that this is actually minus 200. So the 81st term was 0. That makes sense. What I said before, we had 80 terms in between 200 and 0, with the 80th being 2.5. So the maximum value, max positive value of Sn, well, remember the formula for the sum is a half n 2a plus n minus 1d, or a half n a plus the last term. That's exactly the same thing. So what is easiest to deal with? Let's go with so u80 is going to equal u81 because remember we're just adding 0 for the 81st one, and it's going to be a half times 81 times 200 plus 0. I chose to do u81 because then I can use 0 here rather than 2.5. I got a slightly more awkward number there. So I'm just doing half of 200, which is 100. 100 times 81, and I get my answer, which is 8,100. So there's different ways of doing this question, but essentially you just need to work out how many terms there are and then substitute it into the sum formula.